Hello class, today we're going to talk about how to build this part and this part using Inventor. First thing we want to assess, let's start with this guy right here. We're going to assess what dimensions do we need, what does the part look like. If I look at this in detail, this one actually gives us a detailed drawing, so it makes life easier. When I look at the elements of this part, the three-dimensional object tells me what's the front view, guys. This is the front view, okay? Because that's where that position is. We have a side view over here. What's this view? It's the right side view. And this technically shouldn't exist because this view right here is technically incorrect unless there's a sectional somewhere on this drawing allowing us to do that. This view should have a sectional reference because this is a what's called an auxiliary view. Okay? And this technically is the top of the part, but it's in the wrong place if you look at it. Because this is a metric drawing. The units are metric. I'm gonna hold my monitor here. 1 second, sorry. The units are in metric. Cannot write. Even when I have a pen, I can't write. So what angle projection is this, or should this be? First angle projection, okay? So these two views are correct. This one technically is in the wrong place. If let me hit erase, sorry. If it really is intended to be in the top view, what should have been done to make this view clearer? This view and this view are technically both auxiliary views. They're auxiliary views. Okay, they're really not primary views. Primary views are front, right, top. Both of those are what we would call auxiliary views. All right, so please make a note of that. With that in mind, when we're trying to pull information down off of this, we have to think about what the views are giving us and interpret that into a model. Later on, we're going to teach detail drawings. I did erase it all, I'm sorry. But it's in the video. Later on, we're going to go over how to detail a drawing like this. I have many issues with how this drawing is detailed. From dimensions being inside parts, see that? That's a big no-go. We never do that, okay? To this, which makes me horrified to see this dimension there. You would never dimension a diameter like that. That's a big no-go. So when you look at this drawing, please appreciate the reality that it is nowhere close to perfect on detailing. Got it? It has a lot of bad habits in it that are really, really bad. Okay? You shouldn't do most of what's on here. You know, that entire view now is highlighted. You notice that? This view I can tolerate. I'll say okay to this and this, sorta, kinda, but not really. I'll explain later. I'm okay with this. I'm okay with that, and I'm kind of okay with that. Do you see that? But when you get to detailing, when we have that conversation, all of this, I give you a big fat no. Got it? This is okay. This is probably the only view that's really good. When it comes to detailing, this one's a good view on detailing. This one's a good view on detailing. The other two need work. And the work can be in the form of we need more sectionals, we need reference, you know, there's stuff missing. I know how to look at drawings, so that's why I know this was an auxiliary view. And that's why I knew this thing up here was an auxiliary view. But if you don't look at drawings regularly, you honestly wouldn't know. The views are poorly tagged. A horrible tagging. My section lines are totally missing. I should have a section here, or at least through here, identifying this. Got it? A sectional reference, an auxiliary sectional reference. I should see that, I do not. Ditto with this thing. This thing should have some type of sectional to tell me that this is only useful when it's a sectional view, okay? A sectional view. Both of these are really sectionals, which are referred to as auxiliary views. They're views that are in addition to the standard views. Got it? In the most generic term, an auxiliary view is a view of a model that's in addition to the standard views. Specific type of those are called sectional. Okay, so this drawing needs a lot of work when it comes to that piece. So later on, we'll have that conversation. For now, let's talk about at least how to build it, which means you got to be able to read this thing. So that's why I did that first. So what units of measurement are we using? Metric. So should I just click new? Woohoo! And we're good to go. What's wrong if I hit new? We don't, it's the default Inventor units of measurement are inches. You got it. So that's why it's a no-go. You got to go into new. When you're in new, you have to open up your options. You need to pick metric. And now remember the difference between DIN and MM is literally the dimension style settings. I'm not going to worry about that until we go to detail drawings. But they're both metric. So I'm going to pick millimeters. MM for the part file. Got it? And we're going to hit create. Okay. As usual, you've got to go and turn your planes on. That's a recommendation on my side to turn them all on the fly. You hold your shift key down, pick the first one, pick the last one, and then you can pick visibility. Go home, as I always say, because it looks like a little house. I don't mean get up and leave. I just mean go home. Okay. We know where the front view is. We know where the right side view is. Now, the big question is, how the heck do we start this part, right? Should be the question of the hour, right? This thing can be started multiple ways. Extrusion, a simple basic extrusion, like I say, you build a part and whittle away at it, a whittle at a time. Doesn't seem to work here, does it? Extrusion, just a simple extrusion won't get this thing done. This thing has multiple elements to it. How you begin actually has a high degree, in this case, there's a high degree of flexibility in how you begin this part. So the method I'm going to give you is not the only method. Please remember that, all right? As I've said before in class, you have multiple ways of modeling, so please do not think that just because this video says to do it a certain way, don't get wed to that method. And don't go watching this video later on saying, but Ms. Sherris told me to do it this way and I'm doing it this way. Is this okay? The answer is yeah. You've got your own way. Don't worry about it. For me, the way I'm going to start with a part that looks like this, I'm going to go for the yoke. I'm going to look at this piece. Okay? All right. Then, see, when I use my computer, I get to use colors. I'm going to go for figuring out how to do this basic shape, maybe. Okay? Maybe. We'll see. And you'll notice how I said that. We'll see. You'll be like, but how do you not know exactly what you're going to do? You never know exactly what you're going to do, because when a client gives you a model, they're never going to give you a detailed drawing. They might say, hey, we found this in our records. This is a product we've been making for the past 50 years, but the drawings are done by hand. That's, yada, yada, yada. We need this updated on Inventor. We hired you as the intern. Get this done. You never know what you're going to get when you start at a place. So I'm going to start looking at the yoke and say, let's build that. So I'm going to go into this plane. If you ask me why did I start that way, I'm going to tell you it's up to you. Again, let's see, how do I begin? I'm gonna start with a circle. As usual, I use my constraints, right? Use your constraints. Make sure I locked it into the center. Okay, I'm gonna draw 2 circles. No waiting. I'm going to draw a line across. Look at this. I'm going to go as far as I can visually without putting any numbers in. Do you notice that? And I'm just going to be random. I'm going to draw something over here. Just random. Very random. Okay, there you go. This guy, you see how now it's so random. Look how wonky it is, right? We know that this side of the object, let's see, we know that this side of the object and this side of the object are aligned with each other, right? And we know that this shares the same center. Okay? So basically what I drew, or what I'm going to draw in a rather random manner without any dimensions, as you could tell, whoops, there we go, is essentially this shape that you see here. Okay? You can do it whatever way you want. I'm just giving you a method, not the method. Get that? Okay? There is no the method, please. Yes, you're going to have people that have, 50 opinions, just like I have in welding. You have no idea how many opinions that there can be in the room in welding, especially if you've got a bunch of people with 30 years experience. It's quite interesting. All right? So it's no different here, by the way. I don't care what it is, whether it's welding or CAD, it's everything. So I'm choosing to build this a certain way without a lot of thought to it. I am going to turn around and start trimming out of the modify commands. I'm going to trim away those elements that I know have to go. So I have something that looks like this. This line is broken. It's not attached to anything. So is that a problem? Yes, it is. The line over here is also broken. Is that a problem? Yes, it is. So at least make sure that it's connected. One of the things I do want you to get a habit of, you see where it says look at? Look at, when you click on that, all you do is pick the plane, click on look at, and boom, rotates you to that plane. The other method I've shown you already in class is obviously you can control everything using the cube. I have a habit of using the cube, but I did want you to be aware of that little feature right there. By the way, if you ever wanted to orbit around like this, that's this guy right here. And then when you get lost, go home, get back to your front view. There you go. Cool. All right. Now, we know what? Ooh, that's still broken. You see how I moved it around? You're going to hear me say stuff like that. Ooh, that's bad. That wiggled it too much. You might say to me, Ms. Sherris, I don't know if this is constrained correctly. My answer to you is going to be wiggle it, literally. See that? If you move it a little bit, you'll find out what's attached and what's not. Obviously, this is detached. So now I can go, now the question is, how do I get it attached? Sometimes it wants to behave, sometimes it doesn't. See, it doesn't want to attach. So a simple way to do it, you go out here, go to your constraints. You can do this guy, which is coincident. So you can pick this and this. That's one way to attach. Okay? If it doesn't want to behave. Okay? Just figured I'd let you know. Because that never has happened, right? That happens all the time. Now, getting this up in the correct spot, the best way to handle that, again, constraints, you have something called collinear. I can pick this guy, and I can pick that plane, and it makes a collinear to that plane. Okay? This is the first sketch. Remember that? This is the one that you do want to control with the plane usage. Every other sketch, you want to attach it to the part itself as much as you can. Remember that. Now, size of the geometry comes off of a different view. 72, that's the distance from centers. And then you have the radius of 9 on this side, which means you have a radius of 9 on the other side. What I'm looking at right now is this information with this information, because these are the two things I need to determine the edges of this part, okay? The way to constrain it is dimensional now, not geometric, from end to end. I'm going to go up here, and what am I going to do because I'm lazy? We've had this conversation already. You know how lazy your teacher is. 72 plus 9 plus 9. Yes, I can do the math. That's not my problem. It's obviously 72 plus 18. You can do that too. And you could do it in your head. I'm trying to show you a different way so that you understand that the software does let you input math equations. Literally, the whole equation, like function of x, yada, yada, yada. Remember that? So this thing will do the whole darn thing. When you hit OK, there you go. It types in the final number. Cool? Now you're going to tell me, and I agree with you, the left side is not matching the right side. Yeah, so how do we fix that? Well, yes, you can do it dimensionally, or you could do it geometrically. Remember the two types of constraints, a dimensional constraint or a constraint of geometry. I'm going to apply equal. Equal means that the two objects share the same length, not the same properties. When I say properties, hypothetically speaking, that could mean a different color. That's pretty much it when it comes to this product. Line weight, if we wanted to get into that, but those types of things. All equal means in our purposes for this thing is dimensions. So this and this can be the same dimension. Poof, there it is. Cool? Now it's centered. Naturally centered. Why? Because my original circle, I centered it intentionally anyways. So by default, now everything centered itself. Now, of course, the question is, this is centered? Yes, it is. This is centered? Yes, it is. So you see how everything else locked in nice. We just had a circle and a line that didn't, this line, I mean, wasn't centered correctly. Now everything is centered properly. Now all we have to do is put in our dimensional constraint of radii. Okay, this radius is going to be what? Oh, they gave me diameter. Shucks, what do I do? Take the diameter and divide it by 2. Wrong diameter, though. 36, I know what it is. That's not why I'm doing this. I'm showing you the math, okay, people? 36 divided by 2. I'm doing that intentionally so you understand you can operate faster. Yes, it's good that you know how to do it in your head. That's important. I agree with you. But it's equally important to understand how to work efficiently and to understand how to use math in application. And this is an application. No, you're not going to get this out of your math teacher. Sorry. Can't help them. Did I do this right? Is this okay? Can I tell? Is there anything wrong? I went through the effort of building the whole shape. Was that a good idea? Kind of, sort of, but not sort of. Why? What's going on here? What do we see? Yeah, the centerpiece, the yoke, actually extends further out. You see that? Than the body. So it's like, well, this centerpiece sticks out further. Maybe it would have been a better idea if I just built the centerpiece. Maybe not. Again, remember what I told you. I'm giving you a method, not the solution. I'm making you think through this process. I'm not going to give you the answer, and there is no answer. Remember that? There's always more than one way to do anything in CAD, so don't get hung up on what I'm about to do. Please do not get hung up on what I'm about to do. That's intentional. All right. I'm going to ignore the thing that I just mentioned and just keep going. I'm going to change this dimension to 10. That one changed. But what did I tell you guys historically? In order for, is it completely constrained? Do I need it to be fully constrained in order to extrude? No. No, that's not necessary. But it does, how do I tell if I have any missing dimensions or whatnot? Bottom right. Yeah, right here. It says one dimension needed. The other way is it's visual. Now, granted, for those of you that are photo negative, what do you call it? Not photo negative, what's it called? Colorblind. I've had students in the past that are colorblind, and yes, I agree with you. This is ridiculous. The fact that this purple, bluish, whatever it looks like on your screen, and this black, it is really hard for people who cannot see shapes. I agree with you. Down here is your everybody's solution, one dimension needed. Up here, finding that one dimension, wiggle it. Remember what I told you, wiggle it. This doesn't move, that doesn't move. This is the one that moves. So I can lock it in by putting another 10 millimeter in, but you know, I'm lazy. So what I'm gonna do is use the collinear. I'm gonna pick this object, hold my control key down, pick this object, go to my constraints and pick collinear. And then they lock up to each other. What this allows me to do, if my customer comes back and says, I don't want it to be 10, I want it to be 12, no problem. Boom, they match each other. I don't have to go and change 2 dimensions from 10 to 12, I just change 1. Got it? When you have uniformity in your design, if it's like a part like this, you can do stuff like this. All right? Don't worry about it. So I'm going to change it back to 10. And I'm going to hit, let's say, Finish Sketch. I'm going to go ahead and extrude from midplane. Why am I picking from midplane? The main reason I'm picking from midplane is because I see the center, and I'm going to go from here to here, and I'm going to end up with a big block. I'm doing that intentionally because I just want to discuss some new commands with you. All right? Would I do this in reality? I don't know. We'll see. I'm doing it in reality right now. So the width of this thing, we're going to go from midplane, and the dimension is 28. Okay? I'm going to not finish this top because I wanted to show you some other commands for why you do things a certain way. Now I'm going to focus in on the neck. I'm going to focus in on this part, which is another pain in the Badinsky. So I'm going to go to my side view. I'm going to go create a new sketch. And then I've got this thing, and I'm like, okay, what is this thing, right? Whoops. Oh, no, I zoomed too far away. What do I do? Go home. Ta-da! Got it. Remember that? Please? Please remember that. Yeah, I know I'm always, then you can click on sketch and I can say, no, that's not normal too, that's a different product, but this is the command that we use, which is look at, the look at command. Okay, so now I'm gonna just be rather random again. I'm gonna draw a line straight down. I'm gonna draw a line across. I'm going to go ahead and throw in a fillet. What is the radius? Oof. The inside radius is, the outside radius is 12. Okay. I'm going to pick that object, and I've got my 12. Makes a tangent automatically. That's the nice part. Now, okay, I'm going to show you a new trick. There's a neat command that I use all the time when I'm in AutoCAD that I absolutely love. But when I do teach AutoCAD, I teach you how to use it because, yes, I am the ultimate lazy. Offset is a very powerful tool. This is the offset command. I'm going to pick my object, and I'm going to move in that direction. Did you see that? Did you see that? That's beautiful. I moved it without applying a dimension, though. I can now, in turn, go ahead and apply an actual dimension. This dimension that I'm going to apply is 8. Why? Because that's what it says right there. So I put in 12 and I put in 8. My math peeps in the room know exactly what's going to happen. What? Ooh. Did I put the right? No, I did. I put the wrong number in. I wasn't supposed to put 12 there. I was supposed to put 8. All right, much better. Whew. So, my math peeps in the room, what do you notice? What do you think that inside radius is? Outside radius is 12. The thickness is 8. 4. Mathematically, the answer should be 4. Why? Because it's 12 minus 8. Okay? When you have uniform thickness, this is a sheet metal concept, but I'm going to introduce it here anyways. Anytime you're doing a soft radius, a common radius on a bent object, okay, sheet metal is where we can start talking a whole bunch of other stuff, but generally speaking, the inside radius is equal to the outside radius minus the material thickness. Vice versa, if the inside radius is whatever, the outside radius is whatever plus the thickness of the material. Put that in your notes. It's a good thing to know. It's a very useful thing. So because I know that, that is why I know the inside radius is 4. But you'll notice if I try to put that radius in after the fact, you get a message that says, hey, adding that dimension to this thing will over-constrain the sketch because the computer did the calculations already. It knows the inside radius is 4 because you use the offset command from an outside radius of 12 and the material thickness of 8. Got it? When you get this message, it's okay unless you really wanted to put a different number in. Then it's not okay. So please make a note of that. You can leave that number in there, and anytime you have what's called a reference dimension, it's there for reference. It shows in parentheses. All right? So please make a note of that. And that's okay. There's nothing wrong with that. Now you have this shape on the side. That's at 15 degrees, and you'll be like, why is it at 15? And the main reason it is at 15 is because the way I know that is that number right there, 15. It's 15 degrees. And you'll be like, understandably questioning me, saying, hey, well, just because this is, whoops, come on you, just because this is at 15, how do you know this is at 15 over here? Geometry class is going to be my initial answer to you. Way back in geometry class when they talked about common angles and how you derive them, you didn't think this was going to turn into a math class, but remember how they said if this angle is this, it equals this angle. Remember that conversation back in the day? Well, it applies here because it is a commonly understood term. But if you want to question it, the best thing to do is take a right triangle. I don't have one handy on the screen, but you can literally check if these two, whoops, I gotta flatten the monitor for a minute here. If these two things, it's easy to find out if this is perpendicular. Perpendicular meaning that they're right triangles to each other. Okay, once you have that, then you can assess if this is vertical, okay, and this of course is vertical. This is perpendicular, right? These two, right? So therefore, the angle between the two of them is a common angle. That's 15 degrees. This one is 15 degrees. One is given to us, the other is derived. Okay, guys? Got it? That's how you know. You can pull out the math and see it. Good old geometry class. Okay, very straightforward stuff. So if I draw my line at an angle here, intentionally drew it at an angle, I'm going to go ahead and trim this little bit back. I need an angle. So I'm going to go to my measurements and actually identify that angle. From here to that to here. I'm going to specify that angle, but it doesn't want to give that angle to me. Gosh darn it, gee willikers. Stronger words to follow, right? So, so the question is, how do I get the angle I want? What do we remember from geometry class? What is the sum? If I go back over here, whoops. I know this isn't a math class, but you have to understand math to figure some of this out. I want this angle. What do we remember? This thing right here is giving me this angle. So this angle and this angle, we know this is supposed to be 15 degrees. So what's this? 90 minus 15, right? So that is the value you enter here in Inventor. I can't make my pen right all the way across, sorry. So it's 90 minus 15. Get it? That's how you derive that. That's one way, not the only way. There's, of course, more than one way. I keep trying to explain that to you, and I'll continue over and over and over again telling you that. Okay? Now, its position is where? That's the next. We've got the shape. So we've got the correct shape. We have the correct angles built into it. Now we need to get the correct location. Okay, which is right there. Is that where we want to go? Is that the location we're after? Yep. Okay, 50. Why am I picking that location? Oh, sorry. Hand this over. Because that relates to this position. So I put in my constraint, my dimensional constraint, and I'm going to dimension right there, see, from up here to here, and that's where I get 50. Now you notice it's still not fully defined. You notice that? Most of it's blue. And that's the reason it's not fully defined, because I can wiggle it. Remember that? I told you that. How do you find out if it's fully defined? You wiggle it. See what happens. This line is not properly touching that one. Now it is. Is this one? Yeah, it is. That one's locked. See, when you wiggle it, you find out what's missing. So its position is missing. Its position on the drawing is given in relationship to, whoops, I didn't mean to cover the numbers, just circle them. Its position is in relationship to what? Is it really to other locations? Remember what I told you about this drawing and some of the issues I had with it? This is one of them. We're going to do something that I don't like. We're going to assume. But, as I've said in the past, how do we overcome assuming? We put notes on our drawings. Later on, you're going to put a note in your detail drawing, make a note of this, that you're going to do this note, to verify that the neck is centered. Okay? Please, you want to verify that, because this drawing does not perfectly tell me that. I am guessing. That's what assuming means. I'm guessing. Technically, I'm guessing that the center of this to here is 4. I'm guessing that. Do you hear that? And therefore, I'm guessing that this is a particular distance from the end, too, correct? Because if it's 4 from the middle, and we know the width of this thing is what? 28, right? Okay. Get that? See what I'm talking about? I am guessing because the drawing does not blatantly tell me that it's centered. It's assumed. Be mindful of that. It's a very dangerous thing to do, assuming. So be careful with it. So the way that I can build this in to try to get this dead on is I have my center plane. So I'm going to pick this object, pick here. Okay, whoops, first I got to go into constraint and dimension, sorry. Pick the center of this, pick my side wall, go out here, and I'm going to pick this object, f of x, minus, or I'm sorry, not minus, divided by 2. That's how I position it correctly. It's still not done. What else does it need? How do I find out? Because I'm lazy. Just move it. Remember? Move it. Wiggle it around. Find out what else is wrong. Ooh, it did not like that. Did you see that? Interesting. Huh. Did you see what it did there? For whatever reason, that side did not become tangent. Do you see that? So how do I make a tangent? Constraints. There it is. Tangent. Pick the object, pick the other object. Poof, there it is. Okay, that's fixed, thank God. Now what? Man, it's still blue. Okay. So this guy's not in place. Interesting. How do I position that? Well, well, well. Let's look at this. What information do we have that can help us? Again, remember I told you I had problems with this drawing? Did I give you a drawing that was perfectly detailed, that you can just do anything? By the way, I need you to learn from this lesson. You are the ones that are making these drawings for other people to build from. If you are having problem working off of this drawing, imagine what the builder is having. Get it? Be very mindful of how you dimension things, because it really does matter. So this dimension's given. The only other dimension we have that can reference some positioning is this guy, which is all the way down here. So we know that this and this, we know that information. We have absolutely no clue where this point ends without doing some extra legwork. Got it, guys? Do you see that issue? I've had some people ask me historically, well, then why don't you just do this whole thing? You can. You could do this whole thing in one shot. I don't care. But there's more work. It's okay. But it's not a bad thing. It just is. Again, I'm just giving you a method. I'm not giving you the method. Get it? Please remember that. So we're given one piece of information and we know where this point is. So we're good with that point. We know the angle. We know the angle actually can go all the way, right? So it's a full extent. We don't have to end it where it is. We just did it for the sake of, we just did it. There's no rhyme or reason. We just ended it there because that's where it ends in relationship to this shape. Right there. So all we did was this piece. But we honestly don't know where this piece goes here to here. See that? We have its height set, but we don't have its final position set. That's derived by extending our line. Listen very carefully. Extending our line to where this goes, and then we know that that's from the center. Get it? That's how we know. So we have to extend our line. So if I pick, instead of trim, I'm going to pick extend, and I extend my line, it will extend to at a point in reference to where this line is, to be honest. That's what it extended to. If you're wondering where did it go to, it actually went to wherever this extends. Come on, you. See that? That's literally where it went. If you're wondering where the heck did it go and why did it go there, that's what it did, which is fine. We don't care. We'll fix it in a minute. Get it? We know that it is from here to, oh, here. Oh, gosh darn it. How do I dimension that? Oh, geez. I can't dimension that. Why? What's wrong? All right, can you dimension something in space? The answer is no. What would be the ideal solution to figuring this out is, of all things, drawing an extra line down the middle of your part and making it what I will call a construction line. Now I get to show you this tool. See that? A construction line, I'll show you an isometric, allows you to have a reference that you can actually do something with. And in this case, what we really want to do is my next favorite command on the planet that I told you about already, the offset command. How many of you were thinking in your, it's screaming at the screen, or screaming in your head, Miss Sherris, why don't you just offset 20, right? You're right. But I have to show you first what's going on. All right. Now this line's a solid line, so I'm going to turn that into construction. The reason you need to turn these lines into construction is because they will fight you if you don't when it comes to making the shapes that you want to extrude. Trust me. Not trying to make more work for you. You know that? I'm lazy. I'm not going to make more work for you. But what I'm going to do right now, though, I am going to ask you to trim this. Why? Because it's still freaking not constrained. What am I missing? The dimension. Don't forget the dimension. Once you drop that in, whoops, 20. Ah, that looks great. Now what? What's wrong with it? Why will it not stop? What's the issue? Does it really end there? What are we missing? What don't we have? We have one constraint, but we don't have the other constraint. We have, let me erase this for a minute so you can see why it didn't lock in. Okay, that's the piece you need to understand. We have this line. We have this line. So we have this locked in. We have this position over here. We're missing this position. When we add that last dimension from here to here, sorry, going too fast, from here to here, 64, now it's locked in. It demands all those dimensions in there to fully lock in. Now, of course, I'm going to take out 75, and now it's screwed up again. Why? Why is it screwed up now? Whee! What did I take away now? The angle, right? If I put in an angle measurement from here to here, right there, and make that 15, boom. There we are. Now, one of the things that you're going to learn when it comes to creating shapes like this was a complex shape. That's why I went through it step by step. You're going to have future ones. Each one demands its own set of God knows what. Got it? You just have to learn to noodle through it. This one I noodle through it with you just to give you an idea of what it takes to noodle through it. Next thing is how wide do we make this shape? How wide should we make it? Just the neck or the whole length? It's the whole length when you look at it. You see that? Because this shape here goes the full length. See that? That's why. So what is that full length? Do any of the views tell us? Do any of the views tell us, guys? I'm laughing because, oh, there it is. Oh, thank God, it's right there. Phew. I was about to say, where is it? It's right there, 34. All right, so now I'm gonna turn around, I'm gonna go extrude. You should be questioning me in a second, but let me show you first what's gonna happen. I'm gonna pick extrude, I wanna pick mid-plane. I'm gonna identify 34, and I'm gonna say I'm happy, everything's great. You pain in the Budinsky. Watch what happened. I was further away. Watch. You pain in the Budinsky. See how it picks all these different lines? I, of course, zoomed in, but I need you to see what it did. Look what it did. It picked the front and not the back. You see how the field colors change? See that? That means that's what it's going to extrude. And you're going to be like, but why? And I'm going to be like, because that's a solid line. And you're going to be like, well, didn't you make that a construction line? I had put in a construction line, but there may have been a line in there anyways before my construction line. I don't know that because the software automatically puts in reference geometry. So please be aware of that. Pay very close attention because the first thing it's going to do when it picks that object is extrude. And unless you're fully cognizant of what you selected, you might be losing a back end of your part. Okay? Back and front. See that? Again, let me show you from a distance. Back, oh, no, not the whole thing. Whoa. Nope, create, extrude, back part, front part. Now, how do you avoid that altogether? Whatever that line is, turn it into a construction line. Then it stops bothering you. Then when you go to 3D model and extrude, it sees the whole object. Ta-da! See the difference? Okay. Next, we're gonna go mid-plane. And I'll show you what the problem that we have coming up in a few seconds here. We're gonna make it 34 long, 34 long, and we're gonna hit OK. And we think everything's hunky-dory. Peachy keen, fuzzy wuzzy. Is it? Is it? Ah, crapola. It's not. Oh no, what did it do? Gosh darn gee willikers. It extruded straight. And this is a curved body. Do I care? I would if I didn't have to put this in. Anyways, I gotta put, I'm missing a radius, this guy. Yeah, think it might fix itself? I don't know, we'll find out. Did you hear the way I said that? Hypothetically speaking, if that other neck didn't exist, because I know that neck's there and I know it's gonna work. If it didn't exist, what would I do? Here's what I would do. Okay, this is what I would do. I would pick the face of that object. Okay, now notice it goes to the midpoint. Isn't that annoying? Well, that's because it touches at the middle. That's the reason it does that. Now you notice I picked one side, and then I picked the other side, but they don't pick together. To get them to pick together, you have to actually hold your control key down to select both at the same time. Got it? Up here, I can go ahead and create, what's that called? I forgot the term. Create something. Start a new sketch. Get it? Now start a new sketch. Oh, it's still canceled out. That's fine. and I'll just pick the one face. Did it matter if it picked both faces since they're both aligned anyways? Logically speaking, the answer is no. I still need to get in there. So what do I want to do to avoid drawing because your teacher's lazy? I can hold my control key down and pick the edges of my shape. See that? And pick something called project geometry. And that's exactly what it did. What I selected, it turned into geometry. Okay, now I can turn around and extrude that geometry. Oh, ouch. Do I want it to go through like that? Shucks, gee willikers. Do I want to calculate the exact distance of the extrusion? You know, like really, I don't know. Is it maybe 12? No, that doesn't work. I really wish it would just go to that edge, right? Wouldn't it be nice if it just did that? Yeah, guess what? Extrude 2 does that for you. Watch. It's a beautiful feature. When you pick 2, you just pick 2. And it just goes to that face. That's what Extrude 2 does. It does not go through the whole part. See that? It knows to just stop right on that face. Is that not gorgeous? I think so. There you go. So now when you go home, there you have that basic shape to there. Did I have to do that? No, I just did it to show you that you can. All right? Whoops. Yeah, we don't want my emails go away. Okay, so when I go back to my image, I have this radius of 30. I'm just going to go into my, center plane, right? Create a sketch. Going to draw my circle. Can I draw a circle? Can I draw an arc? I'm going to do an arc instead. Why? Just to do it. Arc with center point. How about that? I'm going to pick the center. All right, now I'm going to pick the side over here. And then I'm going to go this way. See that? Is that not gorgeous? Ta-da! If I drew a circle, then I would have to trim the circle and stuff like that, and I'm too lazy. Now the only thing I have to apply is a radius of what? What was the radius on that thing? 30. Then I'm good to go, right? Shouldn't care about anything. I go to extrude. Gosh darn it, gee willikers. Doesn't seem to pick the object. Wow, it picked the wrong object. Shucks, what am I doing wrong? It's an open loop. Remember I told you that at the beginning of class. An open object cannot be extruded. It doesn't, it's trying to find a home. You have to go back to your sketch. You have to project geometry. Select the geometry you're going to project. See that? Got it? Then you can go to 3D model and extrude and you can pick a shape. See? Because I projected geometry, that's the reason I projected geometry. The geometry I projected was that inside arc and the top face. I need a place of closure for the object. It has to close somewhere. It can't just go anywhere. That's why a closed loop is necessary to project, to extrude my object. How far does it extrude? Should be your question. It is parallel to this body. How do I know that? Whoops. How do I know that? Because I don't see a change in material. You see here? I don't see a yoke. So I know this entire body is flush. So I'm lazy. I'm just going to pick 2. Pick how far to extrude. Hit OK. And I'm done. Ta-da! There you go. Cool? Okay. Now, I'm going to go a little faster to finish a piece of this. The rest you're going to do on your own with all the troubleshooting help I've given you. I do this intentionally to you because I need you to figure out the rest on your own. I'm going to noodle a little bit for you, but not too much. This piece you can do yourself because all you got to do is pick that face and create a new sketch. Then all you create on that face is the shape you want to build, which is what? A couple of circles, right? It's got a center circle somewhere, a couple of tangent lines. I'm going to let you mess with that. I showed you tangent already, so if I pick these two objects, just make sure not to pick them exactly at center. I can go to my constrained tangent and say, I want you to be tangent to you. I want you to be tangent to you. Got it? That's how that works. The rest you're going to build yourself. You are right. You're going to say, where do I exactly position this? That information is right there for you. Your position is 64 vertically from the top. Okay, 64 vertically from the top. 64 vertically from, where the heck is that again? Did I leave you with anything to help you with that? Remember what I taught you in the past? Historically, what have I taught you? Don't say nothing. Please, don't say nothing. What did I teach you in the past? What can I do? What can I do? And share the sketch. Remember? Now do you know why I did not trim that line back or turn it into construction? Because now I can take this circle, see that, and actually drop it exactly where it belongs. How though? What do I have to do? Pick the 2 points and then do what? Coincident. Oh, come on, you. This with, won't do it. Why not? Doesn't want to do it. What do I need to do? If it doesn't do it automatically, what do? Throw in a point. We did that with one of the projects. Now you know why there's some method to my madness on why I gave you guys that assignment, right? See that little piece? What am I trying to do? How do I get it there? Let's see if that'll work. Still doesn't like it. Something it doesn't like. Did I do project geometry yet? Am I sharing that sketch? I'm sharing that sketch in here, right? Am I? What do? How do I know? Where is it sharing that sketch? Is it sharing that sketch in here or is it sharing it somewhere else? Where is it sharing it? Sharing it there. Can I share it in here? Can I share that sketch? I've got an unshare. I unshared it now. I see the sketch, but how do I get this to be in here? See the issue? How do I get this object to appear in this sketch? This object to appear in this sketch. This object to appear in this sketch. Will it let me? Nope, it's projecting edges. It projected this. Did it actually project it or is it just visibly there for me to see it? If I turn this off, take away visibility, there it is. Project cut edges. Get it? That's how it actually appears in this other part. So sharing that sketch didn't help me because it would have shared everything. So now I have access to it. Now do I need the point? Now that I have this? Let's find out. I took the point away, take this center, take this end point. And who wants to put money down? I wouldn't if I were you. Got it, guys? Now the question is, how do I look at just that view? How do I get back to that view? Because front view doesn't work. That's at an angle, right? Remember I told you about this guy? Look at your front. That's the one you use now. I'm going to pick the plane that I'm on, and you see how it rotated it a bit? So I can look directly at that plane. That way I could change the size of this object the way I need to. I can make sure these things are aligned correctly. Make sure that they're centered properly. How can I do that? I can throw a center line in through the whole thing, right? Horizontal line across. I can drag this down a bit, kind of line it up. What's the solution? What do I do? Extend your line. Remember that? Oh, why would it not extend? Hold on. Extend. Cannot extend a curve point that is reference geometry. Okay, fine, do that way. It doesn't want to extend it. So if you have that kind of problem, just go ahead and draw the line out. Doesn't matter. Okay, now this one should be horizontal, which is good. This one, we're going to end it there. Now, what do I do with these two lines? Because otherwise they're going to fight me. Turn them into construction geometry. Remember that. They're going to fight you later if you don't. Okay? I want the two end circles to be the same size, so I'm going to use equal. Pretty much everything I taught you to date. That's how I do that. You're going to dimension it. So I'm going to ignore this guy. That's how this piece gets handled. All right, guys? The next piece that you want to figure out is the back piece. You're going to handle that the same way we handled everything else. You're going to start from the mid plane, and you're going to build that back body on your own. The last thing that you need is how the heck do you handle this top? Now, some people will say you should have done it first, Ms. Sherris. Why are you waiting so late? I'm like, okay, I don't care. I'm going to do it now. You can do it one of two ways, but what I want to show you is how not to do it. Let's put it that way. I'm going to go into this plane and create the sketch. If you draw these lines, this is fine. Nothing's wrong with you doing this. Okay. Nothing's wrong with you drawing a circle to the tangency point right there. Absolutely nothing's wrong with you doing any of this. You can then do the tangency constraint like we've already done. Okay. See that? Okay, you can trim. See that? No problems. Absolutely none whatsoever. Then, of course, obviously, you got to put in a dimension. The width from here to here is what? 18? Because that's the radius. Now, of course, it went off center, so how do you get it recentered? Whoops. Don't use a dimension. How can you do it the other way? Can I get collinear? Can I get it to work? There we go. Beautiful. So now you have to trim on this side. Whoops. Let's go back to sketch. Trim. Took the whole thing off. Why the heck did it do that? Is there an edge that's attached to? Now there is, but there wasn't before. Got it? That's why it moved to begin with. This position is not identified. This position is not identified. So you take this object, that edge, make it what? Tangent. Each time I'm doing that, I'm holding my control key down. It's a faster approach to do that. Now, I'm going to teach you something new. I'm going to teach you mirror. See that? Symmetric. I'm going to have you take the whole thing. Whoops. First, let me pick it. I got to pick my center line first. Then I should be able, no, didn't pick my objects. What did I do wrong? Pick all your objects first, then pick mirror is my, it didn't keep it. Darn it. Why not? pick all my objects first, then I pick, what am I doing wrong? You're in the wrong command. Constraint mirror is when the two sets of objects are already there. To mirror is this. Got it, guys? I'm just making you aware. It's a common mistake. That's why I was doing it. Got it? That's the mirror command. When you do it, first thing you want to do is pick the objects you're going to mirror. So that when you do mirror, you want to pick where you're going to mirror from. Let me do that one more time. Sorry. Mirror. Center line. See that? Select the sketch. Activate the command. Or activate the commands, create a new centerline sketch. Your call. Okay? When you pick the mirror, that's going to be my mirror line. So that. Let me open. This whole thing is scrunch shot. There you go. There you go. Got it? Centerline mirror. I need that center line. Do that one more time. If I don't have that center line, I can't mirror about it. So you apply a dimension to the sketch and center line to establish dimensional relationship. Once you have that, then you can pick pattern, which is the mirror command. Okay, so you see how you see mirror in 3 different spots? Select the object. Mirror line. Oh, because I canceled out of it. Shit. Sorry, you didn't hear me say that. Because I canceled out of it. Let me go back because I said it so many times. Did it so many times? I think I lost it. I need a center line. If I don't have a center line to mirror about, I can't mirror. I'll leave that solid line in there. When you go to mirror and you pick the objects you're going to mirror, then you pick the mirror line, and then you hit apply, voila, you get your mirrored part. Done. You have to actually hit done. If you cancel out of it, like some people like to X out of it, they lose everything. They're wondering, why did it go? That's why. Now what you have is a bunch of lines, because I did a big window, and it mirrored everything that was in my window. All right, so that includes objects that I don't particularly want to control my sketch. This I'm going to turn into construction geometry. This shape over here, let's see what this is. That looks good. These look good. Now what? Let's see. The only way I'm really going to know if it's going to work is if when I go to 3D extrude, and instead of adding material, I'm removing material. Okay, now watch what I'm going to try to do. I'm going to try to extrude this object, and that worked. Isn't that gorgeous? Of course, I'm going to say 2. Do not pick through all, trust me. Just don't, please. See that? I can't pick the front. Why won't the front work? Because I don't have a closed loop. I'm missing a line in front. But do you notice how I didn't, quote unquote, didn't care? What can I, just to show you how mirror works. This is my way of showing you mirror. Okay, I'm going to open this up. Did you know mirror exists also for your extrusions, not just for your sketches, okay? So when you have modify, you've got copy objects, blend objects, move, thread, split. Where's mirror? Do I have mirror any of these things? What am I trying to find? The same command? Yeah, mirror. Looks the same. It's not found in Creator. Don't ask me why they did this. I can't answer this question. I'm just telling you what to do. Got it? The features. What do I want to mirror? Well, I want to mirror those features. So when you try to find the features, I tend to pick them off my model tree. That's just how I do it. But everybody's different. My mirror plane is going to be my center plane. And that's it. I hit OK. Done. Cool. That was a convoluted way to explain that to you, but I wanted you to go. I wanted to go through the mental process of what was going on there. The last thing you notice when you have everything, the last thing you do is put in the fillets that you see in that drawing. Not the first thing. I have a lot of students who want to start throwing in the fillets right away, and I'm telling them, no. Stop that. Okay? That's the last thing you do. And that ends this lecture for this part.